Welcome to Geometry Pre-AP. Today we're going to talk about Chapter 10, Section 4, which is using inscribed angles and polygons. You'll need your postulate theorem sheet out and some paper for writing some notes. All right, and be ready for a quiz anytime this week. All right, so our first theorem for today is Theorem 10.7, which says the measure of an inscribed angle theorem, which says that if you have an inscribed angle, this is an inscribed angle, its vertex is on the circle, then that angle is equal to the arc that it intersects, and that would be this blue arc right here, divided by 2. All right, so make sure you remember to know that this is an inscribed angle. Its vertex is on the circle, and so therefore you have an inscribed angle. All right, and so here's a little practice with that. If we look at this one right here, this is my unknown angle. So my angle is x equals to my arc, which is 84, divided by 2. And so I get x is equal to 42 degrees. Here we know a whole circle is 360 degrees. So 360 minus the 190 that I have for these two red arcs here. Leaves us 170 left for this arc right here. And so the angle, which we don't know, is equal to the 170 degree arc divided by 2, which gives us the angle is equal to 85. This one asks to find this arc right here. So we first know that the angle is 75 equals the arc divided by 2, and since this is a proportion, we can cross multiply, and we know that arc is equal to 150. So that makes this is 150, and we know that a whole circle is equal to 360, and so 150 plus 110 equals 260, which leaves 100 left for that last arc. So 360 minus the 260 leaves me 100 left for that arc right there. All right, and so then our next one says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. So this is an inscribed blue or red angle right here. This is an inscribed green angle right here. And since they're both inscribed angles, we know their formulas are angle equals arc divided by 2, and angle equals arc divided by 2. So if this is a 50-degree arc, we know that both angles and so therefore the angles are both equal to 25 degrees. So that shows us that if two inscribed angles intersect the same arc, then they will be congruent angles. So make sure you highlight that theorem. All right, here's a little practice. It says congruent angles, name two pairs of congruent angles looking at this picture. So pause the video and name two pairs of congruent angles. Okay, now if you tried to name the vertical angles in the center, you don't have any letter for those intersections, so you can't do that. So our two angles are ADB and ACB. So ADB is this one, and ACB, which is this one. They both intersect this green arc. And our other pair is CAD, which is this angle, and DBC, which is this angle, and they both intersect that arc. And there's your two pairs of congruent angles. All right, so understanding vocabulary is always important in geometry. First, we have an inscribed polygon, and then we have a circumscribed circle. So an inscribed polygon is thinking about the figure on the inside of the circle, and that each vertex of the polygon intersects a side of the circle. So here's this green inscribed polygon, which is in this case a triangle. And then we have a circumscribed triangle. It's where the circle goes outside and hits each vertex of the quadrilateral. So they are both circumscribed circles, and they are inscribed quadrilaterals or polygons. So you can describe it in either way. So make sure you have that in your vocabulary if you need to pause the video and get that down. Here's our next theorem. Our next theorem says if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And conversely, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite of the diameter is the right angle. So if I take and just draw a circle here, I'm going to draw a few circles. There's one, here's another, here's another. And so if we take these circles, and if I put, say, a diameter in here, I'll put a different diameter in here. And we can do a different one right here. Okay, so if these are diameters, we know that a semicircle is 180 degrees. And so if I put this and make this a triangle and it intersects this diameter, then this is an inscribed angle right there. And so therefore it's half this arc of 180, which makes that a right angle. And same thing goes here. No matter what, each time when I draw it, it's going to be a right angle because that arc intercept is 180 every time, therefore I will get a right angle. But let me remind you that in this last picture right here, that's not necessarily a 45, 45, 90. We'd have to know that these two chords are the same, and we don't know that. Could it be? Yes, but we don't know that for sure. So this is a nice little handy theorem. It kind of goes into the theorem about an inscribed angle and its intercepted arc. Okay, and so for quadrilaterals, when you put a quadrilateral in a circle, it has a few properties, and so therefore we have the theorem 10.10, which says if quadrilateral can be inscribed in a circle, if and only if its opposite angles are supplementary. So opposite angles are supplementary. So that means this angle right here, let's say it was 70 degrees, this would have to be 110. If this was, say, 60 degrees, this would have to be 120 degrees. So the opposite angles must be supplementary. All right. There's not many parallelograms that will allow you to do that. A kite might work also inside of a circle, but be careful. We're not looking at specific figures this time. We're just making sure that you can work this theorem. Okay. So if I look at this one, this is one that I'll practice. There'll be one on the next page for you to practice. If I look at this one, opposite angles are going to be supplementary. So x plus 80 has to equal 180. And then y plus 75 has to equal 180. And so therefore x is equal to 100 and y is equal to 105. And therefore I've got my answers. Now, they'll be a little more complex when we get into the unit stuff. But if you've got a polygon inside of a circle, you need to remember this little property because it might help you find some angle measures that you might not be able to do any other way. All right, so here's one for you to practice. Practice this one, and we'll put the answers up in a second. So. All right, so you should be done now, and so you can check your answer here. Your answer for A should be 45, and your answer for B should be 30. If you did not get these right, make sure you come to class and ask some questions. All right, and so therefore we're done. Your homework will be, or not really homework, but classwork will be pages 10 through 12. There'll be more challenges on page 12, so page 12 is very important. Okay. And that is all for today.